Let's determine whether the series the sum from n equals 1 to infinity of -1 to the n minus 1 over the square root of n converges or diverges using the alternating series test. To use the alternating series test, we need to check two conditions. First, the sequence of terms without the alternating signs must be decreasing. Second, that sequence must approach 0 as n approaches infinity. Let's first look at the sequence without the alternating signs. Our sequence is 1 over the square root of n. Let's check if this is decreasing. To prove the sequence is decreasing, we need to show that a sub n is greater than a sub n plus 1 for all n greater than or equal to 1. Let's substitute our terms. Let's visualize this by plotting some points. As n increases, we can see that the terms get smaller and smaller, confirming that our sequence is indeed decreasing. Now, let's check if the sequence approaches 0. Taking the limit as n approaches infinity of 1 over the square root of n, we can see that this approaches 0. Intuitively, as n gets very large, the square root of n also gets very large, making the fraction approach 0. Since both conditions of the alternating series test are satisfied, the sequence is decreasing and the limit equals 0, we can conclude that the series converges. The alternating series, the sum from n equals 1 to infinity of -1 to the n minus 1 over the square root of n, is convergent.